My name is Akaash,
I'm Sapan Patel.
and our project is TrendCart. In this project, we put forward a dashboard which we predict viral food trends and help grocery store manage their inventory.
The motivation behind our project is because of the rise of popularity in social media platforms like TikTok and Instagram. They have grown rapidly in popularity, and their large consumer user bases have grown with them. On these large platforms, viral trends, specifically in our case, viral food trends, can spread like wildfire. These trends are often opportunities that grocery stores can capitalize on to gain profits. We propose TrendCart, which is an inventory management system for grocery stores that integrate predictions of viral food trends. What are some related works that have already been done? Well, first of all, the most obvious work is traditional inventory management systems. These are things like Market POS and Toast Inventory Management System. The main differentiator between us and these rely on only internal data. They make predictions based on their own consumers' spending habits and don't take into account external data like Google Trends and social media engagements. There are also other similar academic solutions done, like one paper which explored the correlation between Google Trends and Twitter engagements, and they extrapolated that data into the real world, physical world. Another paper surveyed Google Trends for an upcoming unreleased movie. And based on those trends, the authors were able to successfully predict the success that the movie was going to have in the box office sales. While both of these papers are similar to our concept, the main difference are the areas in which they're applied. And finally, they all represent the cyber-physical gap. All of our solutions in the paper aim to bridge the gap between the cyber world, which are trends in Google and social media, and the physical world, which in our case is sales, and that other paper is box office sales.
So our proposed implementation has several different parts, but the foundation of our implementation is our database. We plan to use an SQL type database that is hosted on either AWS or GCP. The goal of this database is to track products, sales, restock orders, and inventory levels. We'll be able to interact with this database through a provided API on the host, which is either AWS or GCP, or if possible, we will build an API on top of this. One potential structure is as shown, where we have three different tables. One containing the products, the product name, category, price, and supplier. And this has a sales table in which each product is sold a certain number of times, and when that product is sold and how much it was sold for. It will also have an inventory table, which is used to track the stock, minimum stock level, and the reorder quantity for each individual item. The next part of our proposed implementation is the actual trend analysis. This will most likely be a script-based API, most likely made in Python, that will additionally be hosted on whichever host we end up using. The goal of this is to watch Google Trends and get any viral recipes. Once we have a viral recipe, how do we know that it's actually interest generated and that people are actually trying to make this recipe? Well, we can cross-verify it with authoritative sources. These can be either food magazines, cookbooks, or any sort of authoritative source relating to recipes and trends related to food. From these recipes, we will then gather ingredients using the Spoonacular database. The Spoonacular database contains many different recipes that are commonly used, and all the ingredients that are listed in them. However, in case a viral trend is something new, a novel recipe, and it is not in the Spoonacular database, then we will find a recipe online, and then we could scrape these ingredients using the provided Spoonacular API, which has a service to do exactly this. In the bottom, you'll see an image that shows what the Google Trends looks like for a specific keyword. In this case, simply recipe shows a specific recipe that is trending very recently. The next part of our implementation is to create the predictive model. This predictive model, the goal of it is to predict the inventory and what will be needed in the coming months. This will be made using a machine learning model in either TensorFlow or PyTorch. We plan to initially train it on Instacart market basket analysis and groceries data. These are two data sets that are found on Kaggle and contain the necessary information containing inventory and sales on a time series basis. The focus of this initial training is to find fundamental inventory needs and when we should restock from historical data. From then, we will iteratively train this on ingredient and statistical time data from our trend analysis. This will allow us to look at the past inventory and sales and the incoming viral trends and predict future needs. We will use an API to present this historical data to this machine learning model and get predictive data back. We will host this and build it, if possible, on the same provider. Finally, the front end. This is where the user actually interacts with the whole system. We plan to build it in React and server and host it on our main provider. This front end, the goal of it is to allow users to input products, manage inventory orders, track sales and inventory levels, and get suggestions when needed. The key feature of this that differentiates us is our dashboard for predictive forecast for inventory needs. This is where we take into account not only the store's previous historical sales, but also the Google Trends information and the viral recipes to predict inventory needs to maximize the store's profit in the coming time. We will also have a real-time inventory tracking and alert system for when inventory is low or viral trends may affect demand.
There are some foreseen issues that we have taken a look at. First was based on one of our assumptions. We assumed that Google Trends data will guarantee virality in our project. However, we cannot be 100% sure that that correlation is completely there. And also, that leads to local trends which may not be big enough in a larger scale to not be captured when we're looking at it from a wider point of view. Another assumption that was made for our project was that virality will actually equal higher trends and demand. This is generally a safe assumption, but it may fall into the cyber-physical gap where we risk overestimating increased virality with increased demand and profits. Finally, knowledge obsolescence is going to have an impact on our machine learning models. In the short term, our initial machine learning models will perform well, but in the long term, it will be adversely affected as consumer patterns naturally do change and evolve as they grow. This is our proposed schedule. As you can see, everything that was talked about in implementation details are here. We'll first obtain the data sets, which we already have. Then we'll actually set up the APIs and create the initial front end. And then the bulk of our project will be done from March 4th to March 25th, which is programming the machine learning models and training them on our data and integrating those suggestions into the front end. And finally, we will deploy the front end and the back end to whichever cloud provider we choose. And we will also have to deploy the SQL database to the cloud provider. And then basically here are all the responsibilities for our deliverables, and these are split up in between us, and we've delegated accordingly based on our strengths.
Here are some project deliverables that we'll be submitting. The first is the Research Jupyter notebooks. This is where most of our testing and experimentation, the data sets and machine learning models will be done. We will turn these two in, and there will most likely be only two of them. One for data exploration and inventory prediction, another one for the Google Trend Tracker and Recipe Scraper. Hopefully by the end, we will have a working interactable web page, which is going to be our main deliverable. Along with this, we will have the source code for it, along with the database API that we may make, the trend analysis process and API for those scripts, the inventory predictive model scripts, training scripts, and writing scripts, and the API for this, and then our front-end code. Additionally, along the way, we will submit project progress reports and learning reports. And at the end of the semester, we'll have a final project report and video demo.
Finally, after implementation of our project, we will come out of the project with skills and learning outcomes that we will have gained exposure in. First, we will have gained exposure in both backend and front-end development, as our project requires a front end to display the dashboard and present the information from the backend. And the backend of our project actually processes the data and obtains it from APIs and whatnot. We will also gain exposure in machine learning as a big part of our project relies on utilizing the cyber data and leveraging machine learning to make predictions for the physical world. Finally, we will get some experience in trend recognition and situational awareness as throughout implementing this project, we will be exposed to many past and ongoing trends through Google Trends and social media engagements, which will inevitably improve our trend recognition skills.